So if it's been rounded to the nearest 10, the limits are going to be at +5 and -5. So the lower bound will be 3365, 5 below, and the upper bound 3375, 5 above. Calculations with bounds always need to work out the limits, so 47.5, 46.5, 24.5, 23.5 before we try and do the calculation. So for a division, I want the highest possible value. So I want the highest value of f divided by the lowest value of n. So 47.5 divided by 23.5. Which is 95 over 47. That's the exact answer, but the question did ask me to round it to 3 sig fig, so I'd give it as 2.02. Proportion, change the sentence into a formula, so R equals K times V. Substitute in the values. And get a value for K. Then rewrite the formula with that K value in it. And then finally substitute in the value from the question. So V equals 1 is our final solution. Take the question and write it as a formula with a K in it. Substitute in the given values. And work out what K is. Rewrite your formula with K in it. And then finally put in the value quoted in the question. Easiest to work with that as an improper fraction. That can't be right. That's better. Oh. Must type my fraction in upside down. So I get 1 over 25 equals 1 over u squared, and therefore u is plus or minus 5. Expand the first bracket. Expand the second bracket. Put the g's together. Put the numbers together. Factorise, want the highest common factor of the numbers, which is 2, and both terms contain a t. Then to get 18t squared, I'd need to multiply by another 9t. To get negative 2tc, I'd need to multiply by negative c. FOIL, so firsts, outers, inners, lasts, and then simplify by putting the middle two terms together. Same with more coefficients, so firsts, outers, inners, lasts, and put the middle two terms together. Factorise means I need to put into two brackets. So I've got an m at the start of each bracket, and then I want two digits that multiply to -90 but add up to -1, which would be -10 and +9. With more difficult quadratics, still two brackets, I'm going to put 30 in both and divide by 30. Then I'm looking for two digits, two numbers that multiply to make -60 but add up to -17. So that would be 3 and -20. First bracket has a common factor of 3. Second bracket has a common factor of 10. And 3 tens are 30. So I've got 10a plus 1, 3a subtract 2. P is always half the x coordinate, so it's -2. -2 squared is 4, and I need 13, so I need to add another 9. If I factorise out 3 from the first two terms, then I halve the x coordinate. Now 4 squared is 16, multiplied by 3 is 48, and I need 50, so I need another 2 more. To expand 3 brackets, start by doing just the first 2, which gives me 20x squared plus 24x minus 32, and then multiply that by the third bracket. So I get 40x squared, sorry, x cubed, 48x squared plus another 200, so that's 248x squared, -64 plus 240x, that's a positive 176x, and finally subtract 320.